we will start the second talk, which will be given by Svetlana Kraeva from our Research and Education Center. So, Svetlana, please.
Hi, everyone. I want to give a talk about the instrument we are currently working on with our team. This instrument is supposed to make easy pressure and permeability map plotting. So the next slide. Firstly, I give some motivation. Why do we actually working on this instrument? Secondly, I will give you a brief talk about what model we are actually using, and then I will explain some method we are using to increase accuracy of the model we are working on. Lastly, I will show you some actual results we are obtaining right now, and in the end, I'll give you some clue about what improvements we are want to add to that model in the future. So the next slide, please. Thank you. So why do we plot pressure and permeability maps in the first place? These maps actually are plotted by a group of experts. They use information from wells like bottom hole pressure and fluid rate, and the information from well test like average pressure in the area and permeability in the area. And they use tools like interpolation to plot these maps, which are then used to forecast fluid production like oil or gas, and give some assessment about capacity of the reservoir, and in the case when we need to enhancement our production, these maps are usually used to give some clue about about supposed state of the reservoir and the other. So we what is the problem with that? Methods which these experts use in their work are not physically justified, and we want to present some instrument to those experts, which is their work, and help them to plot these maps according to the physics of the processes. So the next slide. Next slide, please. Can you hear me? Is everything okay? Oh, thank you. So the models which are used to give some idea about the supposed state of the reservoir can be divided in two categories. Full-threading models, which give high accuracy by themselves, but needs laborious calculations to perform. And the second one, on which we concentrated our attention, is simplified models, so-called proxy models. They give pretty high computational efficiency, but they have lower accuracy, lower accuracy than the full-threading models. So the aim of our work is to increase that accuracy by using a method by using additional information which we can get from the well test. So next slide, and here I will give you some idea of the model we are using in our work. It's based on the boundary element method, where we present our reservoir like flat surface with a contour which is divided by polygon of linear sources on which we have to obtain boundary conditions which are given by the geometry of the reservoir. So using information from the wells, like I said before, bottom hole pressure and fluid rates in the wells, and we can obtain we can obtain pressure from these boundary element sources, and then use that information to obtain pressure in arbitrary points inside the region. So the next slide, please. And here we can see formulation for, before we saw formulation of the pressure in arbitrary point for steady filtration, and here I showed for unsteady filtration model, and also almost seeing the boundary condition. So if you are interested in the more information about this model, you can see it in the article which mentioned in this slide. It's actually the authors of the model. So they present, I guess they present more information, more interesting information about that. So the next we will move, next slide, please. So next we will move to the actual topic of this talk, the method we propose to use to increase the accuracy of the model. Here we have some information from the well test is average pressure in the area around wells. So the task is to find a pressure field which will not only satisfy bottom hole pressure on the well and boundary condition on the contour of reservoir. Also, we want to satisfy this average pressure, which we will know from real data. So we introduce some additional sources which will give some additional pressure around the wells which have condition to satisfy this average pressure and not change the pressure outside this area in which we which average pressure given, and also not change to not change bottom hole pressure. So from on left we can see this additional pressure given from these additional sources for vertical wells, and I want to note that we use in the formulation radius of the circle in which pressure is given. So on the contour of this circle, we have 0. We have this addition equals to 0. And similar we do for the fractures or horizontal wells, but in that case we have not circles but ellipses. So the next slide. So we have the change form of the pressure in the arbitrary point in the region where we have additional pressure from these sources for vertical wells and horizontal wells. The next slide. Here we can see how it works. Actually, this is some synthetic data. On the first picture, we can see pressure distribution for 5 wells in which this average pressure is not given. But on the second picture, we have changed pressure distribution according to the given average pressure. Don't be scared by this picture, because it's some extreme case to show the real difference. But in the reality, when we plot maps, the difference is not such a huge deal. You will see later. And the third picture shows the permeability field distribution. We not only can change the pressure in the well, we also can change permeability on the well according to these additional sources. So we can plot also the permeability fields, yet we not use that tool. I will explain that a little bit later. Why is that? So next slide. So here we have results for cards or for maps, for real maps. We are tested our instrument. Map is not shown, but results of the average pressure around some wells are shown. In this case, we didn't yet used this method I mentioned before, because we didn't had at that time reliable data about the well tests. So this slide is only show you that only using the model we can increase accuracy in comparison to the traditional isobar maps. For working wells, operating wells, we increased results in 2 times. So the model itself can sustain, can get sustainable results. And second one, the next slide, please. Second one shows results with using the information from the well test. So how did we perform that? We had some tests we used to adapt our model, and some which were hidden from us. These 4 is shown in the table. So here we also see the high accuracy in the pressure prediction than the traditional isobar map. As for permeability, in the next table, you can see really high error for that. And I can explain that because, sorry. I can explain that because we used not reliable information, initial information for the model, and that's really made these results really worse. So next one, okay. I don't have much time, and here we can see the difference between two maps. First one is got from data without information from well test, and second one is with using our method. As you can see, there is not much difference, only in few regions, and that shows that our method does not really change the whole picture, but rise the accuracy of the model. And last one. So here are shown some direction in which we want to improve our model. We want to use previous results shown for steady filtration model, because our technique is now used only in that model. But we want to use a steady filtration model because it's much higher accuracy, especially for operating well that new for the reservoir. So I guess I don't have much time, any more time. So
you have 2.5 minutes.
2.5. Okay. Okay. So we also we want to have some instruments to predict production, fluid production, and want to take into account production history, because it's also will increase accuracy of our model. So let's move to the questions, I guess.
Yeah, thank you very much, Sveta. So now we have time for questions. Nikolai Nikolaevich, please, your question.
The question is that, well, I can understand that using some other improvements, you can improve the effectiveness and the functioning of your proxy model. But is the model closely connected with the particular oil field or deposit? Because if we have this model, for example, you've tested, developed it on one oil field, and then somebody wishes with different initial data and some characteristics to use it on the other oil field. Will it be possible?
So as I showed before, 3 cases for 3 different reservoirs with different initial data. So we can use this model to predict or to plot these maps for different reservoirs. But we have also our boundaries with this model, because we are currently cannot plot maps for gas formations or other difficult cases in which 3D models are more benefitable.
Okay, thank you. Thank you.
Okay, so thank you, Svetlana, once again.